Hello everyone, welcome to today's session of Correlation in Python. In this tutorial today, you'll learn what is correlation and why is it needed. You'll learn about different correlation coefficients. You'll also learn how to calculate these correlation coefficients in Python using different libraries like SciPy, NumPy, and Pandas, and also how to visualize these correlations using Seaborn library. You'll learn about a very important theoretical concept that correlation does not imply causation, followed by a quick assessment to gauge your understanding of the topic. So let's begin. What is correlation and why is it needed? So every data set that we work with uses variables and observations. For example, we might be interested to know how a swimmer's height is correlated to their lap timing, or whether there's a relationship between employee age and salary, or maybe what mathematical dependence exists between the population density and the GDP of a country. Correlation basically means the statistical association or relationship between two or more variables. For example, one variable could cause or depend on the values of another variable. One variable could be lightly associated with another variable, or two variables could depend altogether on a third unknown variable. So when you analyze two features of a data set, you'll find some type of correlation. A correlation basically can be of three types. It could be negative, weak, or positive. So what do we mean by that? A positive correlation basically means that in two variables, as x increases, y also increases, and vice versa. A weak correlation means that there is no change on y, whether or not x changes. A negative correlation means that as x increases, y decreases, and vice versa. Now, let us know about different correlation coefficients, which are Pearson, Spearman, and Kendall. A correlation coefficient is a statistical summary that measures the strength and direction between two or more variables and how closely or how loosely they are associated with each other. So one of the advantages of using these correlation coefficients is that they always lie on a scale of -1 to 1, so that we can always determine whether they are loosely or strongly associated with each other. As mentioned, there are three correlation coefficients: Pearson's R, Spearman's Rho, and Kendall's Tau. Pearson coefficient measures linear correlation, whereas the Spearman and Kendall coefficient are always concerned with ranks of the data. So how do we interpret these values from -1 to 1? You can refer to this chart, where higher the value, either on the negative or the positive side, stronger is the correlation on either side. And if it is nearing zero, the correlation is very loose or very little. Now let's see how do we calculate these using Python in SciPy, NumPy, and Pandas library, and also how to visualize these correlations. We start with NumPy and create two arrays, X and Y. X is basically an array having values from 10 to 20, 10 being inclusive and 20 being exclusive, and another array Y having random values of 10 elements. Now remember, for calculating coefficients of correlation, the arrays have to be of the same length, otherwise it will produce an error. We can basically call a CoreCoff function to calculate the correlation coefficient. This is basically a simplified version of X and Y, where the correlation between X and X in the diagonal is 1, and correlation between Y and Y in the lower right diagonal is 1, whereas the correlation between X and Y and X is 0.76. You can visualize this on this particular chart, where we have three different types of correlation coefficients and also the data points plotted on the graph. Now, let's again calculate the correlation coefficient using SciPy.stats library, where we calculate and create an array X as 5 to 10 and an array Y having random values. And then we use the functions, these three functions, to calculate the three different correlation coefficients. You'll notice that these functions produce two values. What are those two values? So the first value is basically the correlation coefficient, and the second value is called the p-value. Now, the p-value is used in statistics when we are testing for a hypothesis. P-value is an important measure that requires in-depth knowledge of probability and statistics to interpret. Now, in some cases, it might be useful to use Pandas instead of SciPy or NumPy, because Pandas offer statistical methods for series and data frame instances. So let's create two series objects with the same number of items, and then we can calculate or call the .cor function to calculate the correlation between these two values. Similarly, we supply Spearman and Kendall as arguments to calculate the other two coefficients. Now, In case we wanted to explore the correlation between all the pairs of the variables, we can simply use the .cor function, which will result in a correlation matrix and calculate the correlation coefficient between all the variables or all the pairs of variables available. Let's import a sample data frame from our systems as test data set. As you can see, this DF is a test data set having various values and columns. Now we call the .cor function on this data frame, and this results in all the pairs of the values where we can calculate the correlation coefficient for the numerical values. Remember, correlation coefficients only work on numerical values and not on any other value. Now, how do we visualize this if the values or the number of variables is used? So the Seaborn libraries offer a very effective way called heat maps to visualize these numbers. As you can see, we use the heat map function on this correlation to visualize the correlation between different variables. For example, the correlation between loan amount and the applicant income is 0.57. The darker the color, more positive or negative the correlation would be, as you can see from this particular legend. Now let's move on to the last topic, which is a very important topic, that correlation does not imply causation. So the correlation only quantifies the strength and the direction of the relationship between two variables. That does not mean that the one variable is automatically caused by other. So two scenarios which could lead to spurious correlations could be that one, there could be a third variable which is causing the correlation. For example, one might say that greater the number of accidents or greater the number of roads in the city, more the number of accidents, which is a very absurd to say, right? That because of more roads, more accidents happen. However, what happens is that the both variables depend on a third variable altogether, most likely the number of potholes. So the higher the number of roads, the more the potholes will exist and more likely the person is to have an accident. Or it could be simply due to chance. With this, we come to the end of this session. Today, we learned about correlation, its different types and uses. We also learned how to implement and calculate correlation in Python using different libraries and to visualize the correlation matrix using the Seaborn library and a couple of important theoretical concepts. To test your understanding of the topic, I recommend to do a quick assessment and feel free to post inquiries and questions that you might have. Post your answers in the comment box and look forward to the next session. Thank you.